Welcome back to Learn As You Explore for another MBOT 2 tutorial. In the last video, which was part A of our tilt-based obstacle detection and recovery project, we implemented tilt detection and the first part of the reaction, the 90-degree turn. In today's part B, we will implement the second part of the reaction, that is driving straight until a line is detected, and then continuing line following with the proportional control algorithm. Before we dive in, here's a quick way to support my work. If you're planning to get an MBOT too, you can use my Amazon affiliate link in the description. It won't cost you extra, but as an Amazon associate, I earn from qualifying purchases. Or if you just want to say thanks, there's a buy me a coffee link down in the description too. All right, let's jump in. If you haven't watched part A of this tutorial, check that out first. We will be continuing from there, so you may feel lost if you directly start with this video. The link to part A is in the description. I'll also include the links to the Python API docs in the description. I hope you've already bookmarked them for easy access. All right, without further ado, let's jump into the code. Open mblock and load the Python project from tutorial 15a. Select the tutorial 15a project that you have saved and click OK. Now let's save this as a new project by going to File, Save As, and give your project a new name. I'm going to just call it 15b. First, we have base power set to 30 here. I'm going to make this 20 so that when the robot joins the line and continues line following, the transition is a bit smoother. You can also leave it at 30 if you'd like. Make it smaller to have a smoother transition, but the robot will drive slower along the line. Make it larger to drive faster along the line, but the transition after the obstacle tilt recovery will be more aggressive. Now let's go to where we left off in the last video, which is this break statement right here. At this point in the code, we have made the turn a left turn if we had tilted the robot to the left, right turn if we had tilted the robot to the right. Once we've made the turn, we currently break out of the while loop, stop all the motors, and end the program. Instead of breaking out of the loop, we want to drive forward at this point. So let's replace this break statement with the mbot2.forward API and pass in the base power as the speed for the robot to drive at. Now that we're driving forward, we cannot say exactly how long it's going to take the robot to reach the line on the other side of the line following sheet. So what we need to do here is to keep checking our quad RGB sensor for the line status. Once the sensor detects a line on any of the four sensors, we can transition back to line following. How can we check for a line on any of the four sensors? We'll use the mbuild.quadragbsensor.getLineStatus API. According to the documentation, this gives us a number from 0 to 15. Let's do a quick recap of what the values returned by getLineStatus from 0 to 15 actually mean. In this table, we have the different values that the quad RGB sensor can report when we ask it for line status. It can report values from 0 through 15, and these are decimal representations of the binary values reported by the four sensors L2, L1, R1, and R2. 0 here means that no line has been detected, and 1 means that a line was detected under that particular sensor. Since our goal here is to identify when a line is detected under any of the sensors, we can see here that as long as the status reported is greater than 0, we have detected our condition. This is because 0 is the only value in this table where no line is detected by any of the four sensors. In all other rows of the table, there's at least one sensor that has detected the line. So as long as the status reported is greater than 0, we are good to continue line following. Let's go back to our code and implement this. Once we've given the forward command, we need to continuously check for line detections by the quad RGB sensor. In order to do that, we'll introduce another recovery mode. We'll call this recovery mode line searching. Now that we've changed the recovery mode, let's add another branch here to check if we're in the line searching recovery mode. Previously, recovery mode could be either left or right or none. When recovery mode is none, we would enter this if branch. Otherwise, if recovery mode was left or right, we would enter this else branch. However, now that we have a third recovery mode called line searching, and we need to do something different in that mode, specifically check for line detections, let's be more specific here and change this else statement to an else if statement. So here we want to say, if recovery mode is none, go and do obstacle detection along with line follow. Else, if the recovery mode is left or right, only then we want to go into this block of code. So if recovery mode is not none, if it's not left or not right, we also need to check if recovery mode is line searching. So we'll add that check in here. Now that we have our conditional branch, let's check for the quad RGB line status using the mbuild.quadragbsensor.getLineStatus API. If the status reported is greater than 0, we have detected our condition, and we will first stop driving forward by using the mbot2.emStop of all API. Now we need to go back to line following and obstacle detection mode. If you look up here, we already have this implemented. When recovery mode is none, we will be performing obstacle detection along with line following. So all we need to do once a line has been detected by the quad RGB sensor is to set the recovery mode to none. Once we get here, the loop will repeat, and since we set recovery mode to none, we will enter this branch of code and perform obstacle detection during line follow. And that's it. I'm sure you're eager to go and get this tested on the robot right now, so let's upload the code to our robot. Make sure that the robot is powered on and connected to your computer. Click Connect, select the COM port and click Connect again. Make sure you're in the upload mode and click Upload Code. Wait for the program to complete uploading, and we're done. Let's test it out on the line follower sheet now. Start the program by pressing button B. The robot follows the line until it reaches the obstacle. At this point, it stops and waits. Now, since the line is on the left side of the robot, tilting the robot left makes it turn left 90 degrees, then drive forward until it detects a line on any of the sensors, and once it does, it continues line following. Now we'll test the right side recovery mode. Now that the line is on the right side, tilting the robot to the right makes it turn right 90 degrees, then drive forward until it detects a line, and once it does, continues line following along with obstacle detection. Wonderful! You've completed this rather complex project and have an exciting demo for your friends and family. Go show off your hard work. I'm sure they'll be impressed. If you found value in this video, hit the like button and subscribe to learn as you explore for more MBOT 2 tutorials. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.